Hi guys, this is David again. In the last video, we have made a very short taste of the product. They call it the only interactive video product on Earth from the playground. Like I said in the last video, 5 minutes is too short for the exploration. So today, we're gonna continue the exploration. I will record every step of my manipulation, except for the payment they have asked, so I can continue my exploration. So, let's go. Remember their website? Let's scrolling down to their project, the birth of the AI. Continue. Now we are in. I will click the play button here. Now it was loading. Okay. The birth of an artificial intelligence. It has, I assume they have 10 episodes. It says 49 RMB to unlock the project. Okay. I will unlock the project so we can continue without any interruption. Okay, I will call the spot. Okay, I have finished my payment. Let's go. I have received some welcome message from their CEO. They hope that this project will make me satisfied. I hope so too. Let's go. Let's go from the recognition of the numbers. Or is number. Play. And right now, I think it's still like a traditional video player. It's buffering the video, as I see here.
这是一个非常利索的项目，所以我就不啰嗦了，先直接给你看看接下来的10分钟我们要做什么。现在你可以在左边这个窗口里随便写。
Like I said, I have tried this in the last time. It asked me to write a number in the left window, so I will write 7 this time. Okay, click confirm.
是不是还挺有意思的？做一个这样的东西其实挺简单的。接下来我们就会一块训练出一个可以识别数字的神经网络。为了实现这一点，我们做的第一件事是先把图片变成数字，让机器可以用来学习。这是一个叫 MNIST 的数据库，库中有7万张图片，每张都是一个手写的数字。
You can listen to this Chinese.
先处理都是28×28像素，也就是说，组成这个数字的是784个小方块，每一排有28个。
I try to follow what they said.
每个方块里只有一个信息，灰度。你可以把灰度理解为这个方块的明暗信息。今天通常用8 bit， 也就是8个0和1来存储每个像素的灰度数值，组合一下一共就是256种可能性。当灰度等于0时，方块是纯黑色；当灰度等于255时，方块是纯白色。在0至255之间，就是由浅到深的灰色。你可以拖动这个竖条，调整这个方块的颜色。理论上，你可以调整这784个方块每一个方块的数值，写出一个数字3。但为了方便你操作，我们把28×28变成了7×7。而如果错了，这784个权重就会自动调整，加上一个 wi， 每条线的颜色也会因此发生变化。
Okay, what I'm gonna do here? It says it will simplify some rectangles, so I can have some trials here. Probably it's a video. I don't think so. Okay, I will choose it to be green, and this one also some green. Okay, I will make it green too. Okay, green. I'll make it dark. So 3.
通过调整每一个像素的数值，我们就可以用784个方块对应的784个数字来表示一张图片了。以这个数字3为例，我们把这784个像素的灰度数值从左上角的像素开始一一记录。x1 等于0 x2 等于0 x3 等于
Okay,
0
now
x4
come
等于
to
0
the boring part.
x5
Where is the pop-up
等于0
window last time?
x8
I'm
等于
gonna
0
close
x9 等于0
this
x10 等于
process.
0 x11 等于0 x12 等于
It's
0
nice that
x13
they
等于
gave
0
me some
14 等于0
interactions
15
so
等于
I
0
can
16
input
等于
some
0
messages.
17等于0
But
18等于0
it was a little
19
pity
等于
that
0 20等于
it
0
was not
21等于
used
0
my
22等于
input
0
in
25
the
等于 0
window.
x27 等于0 x28 等于 0
Instead, it was used some predefined
x31
numbers they have typed in.
x33 等于0 x34 等于0 x35 等于0
No, skip it.
得到的784个 xi 就能组成一个向量。我们先来解释一下向量。向量在数学上有多重理解。在我们的机器学习项目中，你可以把向量理解为一个定义在坐标系中的点。比如，如果这是一个1维向量空间，3就在这里；在一个2维向量空间
Okay,
，3
that's
在这里；
axis.
在一个3维向量空间
Three-dimensional
3
space
在
here.
这里。而我们刚刚根据图片得到的拥有784个数字的向量，就是在784维坐标系中的一个点。我们现在还无法展示784维坐标的样子。
We are talking about the 784 dimensions of the pictures.
好，那现在机器应该如何区分这些比其不同的数字呢？让我们以3个7为例。3的中部有向左突出的那一部分，所以在数字3的向量中，像 x350、x378 这些地方的像素灰度通常会比较高，而这几个像素点在数字7中是空白的，灰度就会比较低。而在下方中部区域的像素，比如 x713、x740，
They try to compare the difference between the number 3 and the number 7
所以将表示这两个数字
for
的
the
向量
computer
都
to
点到784
recognize
坐
this
标系
kind
之
of
后，
numbers.
数字3的向量会形成一个集合，数字7的向量会形成另一个集合。接下来我们要做的就很简单了，我们可以让机器画一条线，把3和7分开。如果在2维空间，我们可以用一条直线把2维坐标系分成2个部分。3维空间则需要一个2维平面分成2块，而在我们的784维空间里，则需要一个783维的超平面完成分割。用感知器公式来表示，就是 W1 乘 X1 加 W2 乘 X2 加 W3 乘 X3 加 W4 乘 X4 加 W784 乘 X784 加 B 等于0。这里的784个 X 就是784个像素点的灰度数值。每个像素点有自己对应的权
For
重
now, I think it
调整
just
权
still
重
belong
或
to
者比
video
就能
part.
改变分割
It's
线
a
的位置。
recorded sessions.
所以我们的目标就是让机器自动改变 W， 尽可能准确地把3和7在784维空间里分成2类。画成图就是这样，每个像素点的灰度值乘对应权重 W 再相加。如果大于阈值 B， 机器就判断为3；小于 B， 机器就判断为7。好，接下来就可以让机器开始自动训练了。
Yeah, asking to train. Ask the
为
computer
了
to
让你
train
更直观
something.
地理解这个过程究竟发生了什么，我们做了一个可视化的3维模型。
We are talking about they have make a
这784个格子就是每张图里的784个像素点。
model.
每个格子上连着的线代表权重，如果权重是0，线就是透明的；如果权重是负数，线是蓝色；如果权重是正数，线就是黄色。这784条线会连接到这个输出点上，如果机器判断正确，就会发绿光；判断错误，发红光。而如果错了，这784个权重就会自动调整，线的颜色也会因此发生变化。这就是一次迭代，我们在左上角标出了实时变化的迭代次数。好，现在你可以点击开始，调整视角，自由地观察这个训练过程了。
Now it was asking me to click the play button so I can have a look through of the training process for the computer to recognize the number of 3. Okay, interesting. Let's go. Okay.
对了，训练一个靠谱的模型需要用到大量的数据。我们这次用的就是 MIS 的数据库里6131个数字3和6265个数字7，一共是12388张图。 你可以在左上角看到训练进度。如果你觉得差不多了，可以随时点击暂停，用现在训练好的模型进入测试阶段，看看准确度。
Okay, 3, 7, 3. It was asking me if I think the training result is okay, so I can click the pause button and to check the results. Okay, I will wait that it will training 100 times. Now it's 70, 97, 99. Okay, 100. I will pause the process. Let's start the test. It says you have only got one chance to test. So
接下来我们会把 M14 数据库里另外1821张图片轮流输入到你刚刚训练好的模型里，看看准确度到底有多高。
Okay, it will start. I haven't clicked any button to continue. Okay, let's see. It wants me to waiting this episode here, but I haven't finished the part here. It was still to see the result here. As I see for the rate here, for the correction rate, is set about around 60%. Should I think that it's a acceptable rate or it's a lower rate? I'm not sure, but the process is quite interesting. And okay, I will give it a rate 7, maybe. I will fast forward this part. Wow, very fast. Now, fast. Okay. I have to go through this process, right? So we have to wait, as the video is not finished here. Okay, it's still around 60%. Can I? Well, I haven't found that part, so we can do something on it. So I can drag it with my mouse. 3-dimension, right? Should I use some keyboard? No? Nope. There's my... Okay. Wow. Where is it? Where is it? Man, it's hard to manipulation. I think this should learn from some 3-dimensional 3D modeling software for how to manipulation in 3D. It's very hard to give it a right angle so I can view it, maybe directly from the numbers. Make it in front of me. Okay.
结果有点差啊，你不会只训练了几秒钟吧？
It says that the result is unacceptable. So
简单的模型能处理的不仅仅是数字，对于所有
let's hear what it say.
用每个像素的灰度数值来表示任何一张图。当然，像素越高，空间维度也更高，训练时间也更长。是不是很简单？当然简单，因为这是第一集，我们把真正难的地方藏起来了。刚刚这一系列的训练过程中，最关键的其实是
Yes, I like to have this angle, but I haven't got a result. I think
而这个自动调整才是整个机器学习和人工智能最底层和最核心的内容。
So I will pause the video here. We can continue the exploration later, since it will jump to the next episode. I will take a short break. See you later.